All right, in this video, we're going to practice converting more polar equations to rectangular form. So here we have the equation r equals 4 cos theta. Now, if you watch the previous video on converting polar equations to rectangular form, I mentioned that there are two strategies that we'll try to employ when we're trying to convert these equations. The first one was we could multiply both sides of an equation by r to get the r squared, because we know that r squared is equal to x squared plus y squared. The second strategy that we can use is we can square both sides of an equation. Squaring both sides of this equation will get us r squared, but then it will also get us 16 cosine squared theta on the right side. And that doesn't particularly help us in this case. So in this case, I think the best course of action is to multiply both sides of this equation by r, and you'll see why after we do it. So let's multiply both sides of the equation by r. That's going to give us r squared on the left and 4r cosine theta on the right. Well, we know that r squared is equal to x squared plus y squared. That's why we wanted to get the r squared in the first place, so that we could replace it with x squared plus y squared. But then we also know that on the right, r cosine of theta is equal to x. So in this example, multiplying both sides of the equation by r helps us in two ways. The first way it helps us is on the left side of the equation by getting us an r squared, which we can then substitute x squared plus y squared for. And on the right side of the equation, multiplying by r gives us an r cosine of theta that we then can replace with x. So now we have all x's and y's in this equation, no r's, no thetas. Because we have all x's and y's and no r's and no thetas, then this equation is in rectangular form. This example is a little bit different. Here we have r equals 2 cosecant of theta. In all of our previous examples, we've worked with equations that have sines, cosines, or tangents, because we know that sine, cosine, and tangent helps us relate the rectangular coordinate system to the polar coordinate system. But here we have a cosecant of theta. So the first thing I want to do here is I want to start by rewriting cosecant of theta in terms of sine. So that would give us r is equal to 2 times 1 over sine of theta, because cosecant theta is 1 over sine theta. Or another way to write that would be r equals 2 over sine theta. Now I notice if we multiply both sides of this equation by sine theta, on the right the sine thetas will cancel out, and on the left we will have r sine theta. So we have r sine theta equals 2. And r sine of theta we know is y. So we have y equals 2. So this polar equation, r equals 2 cosecant theta, is the equation y equals 2 in the rectangular system. So really this is just a horizontal line with a y-intercept of 2. All right, let's take a look at this one. Here we have r equals 2 over 1 minus cos theta. Now, I don't know about you, but anytime I'm solving an equation, I always want to get rid of fractions. So in this case, I want to get rid of the 2 over 1 minus cos theta. And I can do that by multiplying both sides of the equation by 1 minus cos theta. When I multiply the right side of the equation by 1 minus cos theta, the 1 minus cos thetas cancel out and leaves me with just 2. On the left side, when I multiply r by 1 minus cos theta, I get r times the difference, 1 minus cos theta. But now I'm going to distribute the r to get rid of the parentheses, and we'll have r minus r cos theta on the left. And this is helpful because r cos theta is x. So now I have r minus x equals 2. Well, now I'm right back in the situation I was to begin with. Let's add x to both sides of this equation to get r by itself. and we'll have r is equal to x plus 2. So now I have a choice to make. I can either multiply both sides of this equation by r or square both sides of this equation. And in this case, I think it's the best bet to square both sides of the equation. That way I don't have a lonely r hanging out on the right side of the equation that I can't do anything with. So let's square both sides of this equation. We'll have r squared is equal to x plus 2 squared. And I'm going to need some more room, so let me move all of my work to the left just a little bit. And now on the left side of this equation, we have r squared, which we know is x squared plus y squared. And that's equal to x plus 2 quantity squared on the right. Now, we have all x's and y's, so technically we are in rectangular form. There's really no need to do anything else here. But I see that this is going to simplify just a little bit, so I'm going to take some extra steps to go ahead and simplify this now. Let's go ahead and simplify the x plus 2 squared on the right. So we'll have x squared plus y squared on the left is equal to x plus 2 squared. That's a binomial squared. So when we FOIL that out, we'll have x squared plus 4x plus 4. And now I notice that if we subtract x squared from both sides of this equation, those x squareds cancel out and leave us with y squared equals 4x plus 4. And that is this equation in rectangular form.